So far we've talked about a couple different things to do with arrays. How to declare an array, the syntax is pretty easy. If you're going to pre-initialize it, if you're just going to fill it with data, that's the syntax. If you're going to declare it, there, now we have an array full of 20 values. Once you do that, if you're going to iterate through it to print it out or to add up the values or whatever, you can use two different types of for loops. One, you can do iterate by index, which is where you declare a counter, an index, and you go through the length of the array while like that. And then you do something with that value. Whatever it is, adding it to a total, printing it out, whatever you need to do. Could just be system.out.println IA sub x, whatever. If that's all you're trying to do is print it out. That's iterating by index. There's also iterating by value. Look at that. I was just in Python, so I'm putting little Python comments in. Alrighty. So iterate by value is known as a for each loop. And I keep forgetting whether this textbook calls it something different or not. For every value in the array, print that value out. Add it to a total, print it out, whatever you're going to do with it. Hopefully, you might agree that this syntax is sure a lot cleaner than this one. But there are times when you have to do it like this. And the times are when you want to actually modify the array as you're going through it. Here, this value is just a copy of the element. So if you change it, if you set it equal to -1, it doesn't change the original array. The other drawback is if you have a partially filled array. Remember, a partially filled array is one where you don't know how many elements are in it. Or but it's certainly not all the way out to the end, right? A partially filled array, you may have 20 elements allocated, but only the first 10 are good pieces of data. So you can't use a range-based. That's the other term for it, range-based or for each loop. You can't use a for each loop well, that's interesting. It's indicating that it's only recording from here to here. I will have to keep that in mind as we lecture. Okay, so if you have, this is not good for partially filled arrays. So let's put some comments about when you would want to use each one. That is going to bug the jabbers out of me. Okay. All right. So use an index-based loop when you need to change the values of the elements in the array, or when using a partially filled array. Otherwise, using for each or range-based loop can be handy, just because of its cleaner syntax. Also, this will look real familiar to you Python programmers, because you Python programmers would write it like this, for value in IA, right? Searching an array and copying an array. To copy an array, you just have to allocate a new array and then rip through the original, copying all the values into the new array. So say we had our original array called IA, we want to copy all the values into a new array. You would have to allocate a new array to the same length as your old array. And then you could use a index-based for loop to copy all the values in one by one. I hope I didn't type I++ in index and get them mixed up here, but I probably did. Yeah, right there. Am I going to change it to be I, or am I going to change these to be index? And then I didn't call this index here. Man, I was sloppy. Okay, if y'all were looking at me looking like I was crazy, then this is correct. The other was not. I was mixing up my words index and I, and then for some reason I threw in an X there. Must be my headache. Okay, so then you can copy into the new array at that specific value, that place, the value from your original array. That copies it. What if you want to search an array? To search an array, you start at the beginning, you keep going until you find the element, and if you hit the end of the array and you never found it, then you indicate that you didn't find it. So you could declare a variable called found, set it equal to -1, and then you could write a while or a for loop of some kind. So starting at the first position, keep going as long as your index is less than the length of the array. If you find it, great. If the array element at that specific index is equal to your search value, ta-da, you found it. Set found equal to the index and break. I need to put curly braces there. And so by the time you're done with it, by the time we get here, if found still equals -1, we didn't find the element in the array. Otherwise, it equals the index where that element is. Okay, so copying an array. I'm going to post these notes, by the way. Then searching an array. Hope that makes sense. You just start at the beginning. This is going to be your flag as to whether you found it or not. If it equals -1 after you go through the loop, then it means that you never found it. If you do find it, you copy the index value of that position into the found so that you can then do something with it. Change it, add it, whatever you needed to do with it. Copying can be done also more, I won't say more quickly, but with a single call to a method. So that you don't have to write that loop. Do I want you to write that loop? Yeah, but you need to know how to do it by hand. So here I'm just going to a web page called Copy an Array. And they've written a method that copies the array. But there are other methods doing it too. There's one called arrays.copy. And then there's another one called system.copyArray. Let's go ahead and open up NetBeans and then just get those going. So the deal is that the developers of Java knew that you would be copying arrays so often that they provided a way to do it. And one is inside the system class, and then later on they developed an arrays class with a whole bunch of extra options for handling arrays, including sorting. So I'm going to make a new one, new project. I gave it the name of array copies, but I should have just called it November 28 to make it easy to find, whatever. I'm going to remove the package statement. Move it to its correct folder. All right, let's declare our array to be weird as a static member of our class. Type some numbers in that aren't in order. All right, there we go. Now let's write some functions that will copy the array. We're going to write a function called ourCopy. Excuse me, a method. Public static int, and it's going to return the copied array. Copy array. It's going to take, you know what, I shouldn't have done it that way. That's really tacky. Let's actually move this array declaration into main. So I'm going to take that out. I'm going to make it part of main, which means I'm going to have to remove the word static. Okay. So what copy array does is it takes an array of ints and it copies it. So we're going to need to declare a new array. This is going to be just pretty much the same code that I typed into Notepad. Int NA for new array is equal to new int the length of the old array, ia.length, and then a for loop. Print I is equal to 0, I is less than ia.length, I plus plus, NA subscript I, the new array, is equal to the original array at subscript I. And then just return that array so that we can do something with it. And notice it's offering to fix this for us. It says, hey, you're doing a manual array copy, you fool. I'm going to leave that alone for now. But I'm going to make another method that uses that. So I copied it and I pasted it, and I'm going to let NetBeans offer me the fix. So right now I have a function called copy array. I'm going to just name the second one copy array 2. We might give these better names later. But for copy array 2, I'm going to let this little warning here replace with system.arrayCopy. And there we go. It put it into a single call, where you specify the source array, the starting position in it, the destination array, the starting position in it, and then the length. And usually your starting position in both is going to be, 0. But if you want to copy the last 100 elements of this array into the, to make starting at position 100, I want you to copy them into position 0 of my destination array, and then it would be moving them around, or vice versa. If you want to copy the first 10 elements of this one, but put them in as elements 90 through 100, then you'd put a 0 there and you'd put a 90 there. So it's nice to be able to do that. And then there's another way still. And The code that I was just looking at was trying to measure the performance, that web page, of which one is faster. And we'll scroll down the web page and see if they have any comments as to that effect. So copy that code. Copy 2, and let's paste it and make copy 3. And this one is going to use the arrays class. So because I don't quite remember the syntax, I'm going to type arrays dot copy of. Well, that's pretty simple. This is going to be the easiest syntax of all. Where it says int na is equal to, just erase all of that stuff. Erase all that stuff. And here's what copy 3 is going to look like. Int square brace na is equal to arrays dot copy of, and we're going to give the original array name and then the length. Or is that what the second one is? I don't recall, so I'm going to look at the Java doc. I'm going to highlight the word copy of, right click, do show Java doc. Yeah, so it takes an original and it takes a length. So this next one needs to be ia.length, like that. So here's our two versions of it besides the one that we wrote. I'd rather use this one, arrays.copyOf, just because the syntax is simpler, right? This one required me passing in 5 things, 2 different arrays, 2 different starting positions, and a length. This one just requires me to do 2. This one goes ahead and allocates the space for you, so you don't have to do what we did here. Here we had to pre-allocate our space so that we could then pass that in as an argument to the array copy method. This one does the allocation for you. So the syntax winds up being very nice. You wouldn't even bother having a copy array 3 function method in your code if all it did was call copy of, right? Because this is only one line of code, and if your method is encapsulating only one line of code, it's probably silly to make it a method. So hopefully all 3 of these things would do the same thing. We could try testing that. Int A2 for array 2 is equal to copy array of our array. I'm going to call that A1 because we called our methods copy array 2 and copy array 3. So A1 is equal to copy array. Int A2 is equal to copy array 2, our second method. And int A3 is equal to copy array 3, the array, like that. And there are more ways still, but that's enough. That's enough. Let's write a little function that'll print out the array. I keep calling them functions. They're methods. That's what I get for walking out of Python into here. So public static void print array that takes an array of ints. System.out. Print the word array equals curly brace. Now let's have a for loop that'll print out all the items. I'm not going to take for every int value colon ia for every value in the array. System.out.print. I'm not liking how this is turning out. I'm going to change this to an index based just to do something specific. So delete that for loop. For int I is equal to 0, I is less than ia.length, I plus plus. And if we're not at position 1, so if I is greater than 0, we want to print a comma, system.out.print. Notice I'm using print rather than print lines. It's because I want the entire array displayed on one line. Print out a comma followed by a space. Otherwise, or not otherwise, we're not putting an else in here. Then after that, system.out.print the value itself, plus a space. And when we're done with it, we want it to go to the next line like a typewriter, so we're going to do a print line here of a closing brace. Just like we have an opening brace there, we want a closing brace here. Except it's not value because it's not a range based. What should I put here? I want to get each element out in succession like we've done in all of our other loops. I don't have a variable called value. Instead, I want to print out the array. So what am I going to put here? All right, I can scroll up and let y'all see, but
Print array and I.
yeah, it's going to be IA subscript I. Exactly. So print IA's square braces subscript I. And this should have been system dot, I got distracted, out dot print line. All right, now we have a cute printing function. If we wanted to make it cuter, we could let ourselves pass in a name of the array, but I don't think we need to do that. We all have that typed in. If you run it, do you not getting any syntax errors? It's not going to do anything because we haven't actually called any print statements, but I want to make sure that it at least isn't giving us syntax errors. All right, so I was able to run mine. How about y'all? Getting syntax errors? Okay, cool deal. So we just copied our array 3 times. So let's do this. Heck, let's just print array A1, print array A2, print array A3. All right, looks like we do have 3 copies of the array, so our code did work successfully. Now that was a whole bunch of fancy schmancy stuff inside of our print array code. Did we need to do that? No. We could have made it to where it printed 1 number per line. Hopefully you know how to print the array just 1 element per line. So after this code, print the A3 array, or the original one. Print the array, the original array, 1 element per line using a index for loop and a for each loop. So you can have 2 for loops. I want y'all to go ahead and do that yourselves, and then I'll do it up here, of course.
Can you go up to where it says copy array 3?
Is that high enough, or did you need to?
Up where it says public static int.
Okay, copy array 3 is not going to help you. Copy array 1, this gives you a real good idea of what it should look like. Alrighty. I don't think I hear any typing, so that means either y'all are stuck or that you've already done it. So I'm going to do it. Print using an index. Alrighty. For, I need an index variable. I like using I for my indexes. I is equal to 0. I is less than array.length. I plus plus. System.out.println. I don't want to just print out I. Why? Because that's going to print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not real useful information. Instead, what do I want to print? Real similar to the question I just asked 3 minutes ago inside of our print array method. Yeah, array subscript I. All right, so that's doing it with an index loop. Now let's use a for each loop. For int value in the array, system.out.println that value. I have messed up the syntax. What did I do wrong there? I bet somebody could spot it. Yeah, colon. Yep. Alrighty, and so now it's really noisy and messy. It's not all nicely formatted, right? Is there a arrays method that would convert it to a string for easy printing? It'd be neat if we could just do this. String s is equal to arrays dot, and then have it, oh, well, what do you know? There are some toString methods. So arrays dot toString, and then just pass in our array, and let's print that out. System.out.println s. Now the customer's not going to want to see it formatted in the fashion that we see here, but when we're debugging it or writing things for class, maybe that'll be enough. Yeah, see that? That was a lot easier than what I wrote in order to do that. Not really easier, but you know, it was just a single call rather than writing a method, which is what we did up here. That did essentially the same thing. We could make it do exactly the same thing if we cared. So back down here. Now if I ask you on an exam to print out an array using a loop, don't put arrays.toString, because that's not using a loop. I'm sure that somewhere in the background there's a loop being used, but we didn't write it. So use one of those two forms of loops. And yeah, you could use a while loop rather than a for loop, but if you can avoid using while, for loops, the syntax are nice and clean. Oops. So what if we wanted the array sorted? Why would you care about sorting it? Well, sorted data looks nice to people, but more importantly, if you needed to search for a value in the array, if it's sorted, then you can optimize your search. And what do I mean by that? Say you had 1,000 names, and they were randomly sorted, and then you start looking for Johnny. You have to start at the beginning. Are you Johnny? Nope. Are you Johnny? Nope. You got to go all the way through the 1,000 in order to determine it's not there. But what if it's like a phone book? What if it's arranged alphabetically? You could start, you know, at Johnny, and you could keep going. I mean, you could start at the first one, but eventually you get to the point where you knew that Johnny wasn't in there, right? You know, when you hit the K's, you know that Johnny wasn't in there. And even better, you can use something called the binary search algorithm, which is where you jump to the middle and you decide, okay, I mean, this is how you really do it in a phone book, right? You just pop open the phone book, and you're looking for, you know, a name that starts with a C, but it pops open to M. You'll go, okay, and then you flip backwards, you know, a whole bunch of pages, and then you hit the F, and you go, okay, well, I needed to flip further back, so you flip it again, and you hit the B. Each time you're dividing that phone book in half. You're cutting it into two, two being binary. It doesn't mean zeros and ones in this case, it means two. That's a binary search. And a binary search is what you do when you play the guessing game. Pick a number between 1 and 100. And so secretly I pick 70, and I ask you to start guessing numbers. Well, you could guess 50. And I would say, no, you need to go higher. And so then you go halfway between 50 and 100. So you guess 75. And I say, no, you need to go lower. So you pick a number halfway between those two, which is like 62 or 63. And I say, no, you need to go higher. And so we have to pick one between 62 and 75. I don't know. I'm not doing it perfectly, you know. And then we say, nope, still got to go higher. So, you know, maybe it took 4 searches, 5 searches, 6 searches, but it sure was better than, you know, if you ask a machine to guess a number between 1 and 100 and it starts going 1, 2, 3, 4, 5. Eventually it's going to get it, right? But it's going to take up to 100 times to get through it. Whereas this might only take 5 turns or less, you know, if you guess it exactly. And there's a formula that you can use to show the maximum number of guesses you would have to make. Let's see if I can remember it. It's not that important, but whoops, did not mean to launch Visual Studio. So log base 2 of 100. It should take at most 7 searches if you're using a binary search algorithm in order to guess that number between 1 and 100. Similarly, if you have a list of 100 items, it should take 7 searches, 7 accesses to determine whether it was in that list or not. But it only works if it's sorted, right? If it's all in random order, then it can't tell. You know, you can't say, okay, no, it was before that or after that. So if data is sorted, you can do some nice searches into it with a very efficient algorithm, the binary search algorithm. But if it's not sorted, all bets are off. You just have to start from the beginning and go to the end. So let's sort that data. And I bet that there's a method called arrays.sort. Let's go find out. I'm just going to type arrays.sort. And that didn't give me much information because there it is. And we sort our array. Let's sort array, but we're going to need to store it. Do we even need to store it, or is that enough? I don't know. Let's print it out again. I'm just going to copy these 2 lines. No, I'm not. System.out.println, parentheses, arrays.toString, parentheses, the array that I just sorted. Close parentheses, close parentheses. That wound up being too long for the line, so I'm going to hit character turn, make it look like that. So this will be the sorted version of it. So I'm going to add the word sorted space end quote plus to my print statement like that. See if that works. Yep, there they are. 1, 1, 2, 3, 4, 5, 7, 7. At the very least, we could optimize our own search algorithm so that if once our value that we were searching for was exceeded by the current value, we would stop our search. We could go back and modify our notepad notes based on that. But there's a binary search method built into the arrays class to determine whether it is in there or not. You Python programmers may remember something like this syntax. Don't type this because I'm going to delete it immediately. If 12 is in the array, do something. Well, let's see if we can write some code that will do something similar to that. We want to see if the value 4 is in this array. So I'm going to declare a search value, and I'm going to set it equal to 4. And now let's use arrays.binarySearch. Arrays.binarySearch. The array name and then the key that we're looking for. So .binarySearch. We're going to search the array, and here's our search value. But we need to store its result. So int found at is equal to arrays.binarySearch. I'll break that into 2 statements so it can all be on one screen. And let's run it. I don't remember if there was a 4 in my data or not. I better print it. Let's system.out.println found at equals plus the found at variable. And heck, why don't we print the search value as well? Search plus, open quote, found at equals, close quote, plus found at. That'll give us some information about it. And it did find it. Add index value 4, coincidentally. Let's see if that's true. 0, 1, 2, 3, 4. Let's change our search value to something that's not in the list. There's no zeros in it. There's no 6s in it. Let's look for a 6 instead. If you use my numbers. If you made up your own numbers, change it. Verify that it works by searching for a number you know is in the array, and then modify it so that you're searching for a number that is not in the array. Okay, so it says 6 was found at -7. Well, the negative means it wasn't found. And the 7 means what index position would it have to have been inserted into in order to find it? 0, 1, 2, 3, 4, 5, 6. I'm not quite understanding that. But anyways, I think this should have gone before that one. 0, 1, 2, 3, 4, 5. It's enough to know that if it's a negative value, it didn't find it. And if it's a positive value, it's the index at which it found it. So binary searches are great. They're far, far faster than a linear search. The linear search is the one that we have looked at. Did I do a search? Yeah, searching an array. Here's our linear search algorithm. We start at index 0 and we just rip all the way through the end, one by one, looking for it. But binary search starts in the middle, and then it jumps into the middle of these, of that, and then the middle of that until it zeroes in on it or it doesn't find it at all. Sorting the array. There are different kinds of sorts. I should just give y'all a video to watch on sorting, but we can simulate it here. Say we have an array with these values in it. It's got a 20 and a 1 and a 25 and a 6 and a 5 and then a 4. And we want this arranged in ascending order. Well, the way the selection search does is it goes, I want to find the first value, the lowest value, and put it into the first place. And so what does it do? What is the lowest value in all of this stuff? Somebody tell me. You can see what the lowest value is. Not the index of it, just the lowest value itself. It's a 1, right? So it swaps these two. It searches the entire array, finds the lowest one, and it swaps them. Then it does it again. We don't need to do it for that one anymore, so now we're searching for one to swap with this one. We want the lowest value, not counting that. So what's the lowest value now?
4.
4. So it's going to swap the 20 and the 4. Now we're going to find the next lowest one.
5.
Yeah, it's getting pretty obvious, right? So 1, 4, 5, 6, 24, 20. Now starting at 6, what's the lowest one? 6. Already done. There's nothing to swap there. Now, not counting all these, which one are we going to swap into that one?
20.
The 20, yeah. So at that point, we're done. That's the selection sort. It's the easiest to demonstrate by typing. There's all sorts of sort algorithms, some of them far more complicated. Why are there so many? Because they're trying to create the most optimized one, the one that runs the fastest. And A lot of them have trade-offs. This sort algorithm works faster than that one, but it uses more memory. So which one do you want to use? Well, sometimes you don't have unlimited memory. You might need to use the one that works in less memory. So there's another one called the bubble sort, which runs through it, comparing the two values and swapping them if need be. Let's do a bubble sort on this one. This was a selection sort. And I'm not going to actually make y'all write this program. But, implement these in code. But say we're starting from there. We want the lowest value to bubble all the way, or the highest value to bubble all the way to the end. Let's do it that way. So we're going to compare these two values. Which one's higher, 20 or 1? Alrighty, so we're going to swap those. This one's going to take a heck of a lot more typing, so I'm going to not continue typing. Okay, then we compare those two pairs. Now compare those two pairs. Are they in the right order? Yeah, they are. How about comparing these two? Are they in the right order? No, so they need to be swapped. All right. Are these guys in the right order? Nope. So those two have to be swapped. And lastly, are these two in the right order? No, they have to be swapped. So after one run through of it, hopefully you can see that that pushes, bubbles it up to its right place. Now we're going to repeat the process. But we don't need to go all the way to the end because we're sure that this is done. So now we only need to go and check these values. And I'm going to stop after we do this. After we do this, So 1 and 20. Is this the correct order?
Yes.
Yeah, so there's no need to change it. I'm going to repaste it. How about 20 and 6?
No.
Nope. So you see why I like the selection sort better just for purposes of typing it in on the screen? All right, 20 and 5, clearly not in the right order. And you can see why I'm not going to run this all the way through. 20 and 4, not in the right order. And we just stop there. We don't need to keep going at that point because we were sure. I've messed up something, but I don't care. All right, they're like that. Now we know that these two are correct. We do the same process again, pushing up the highest value. 6 winds up there. Then we do the whole process again, pushing up the next higher value. 5 winds up there. Do it again, pushing up the next highest value. 4 winds up there, and by then we're done. Now it may look like this is much more complicated, much longer, because I had to type a whole bunch of stuff. But this one had to do just as many comparisons to get it to work as this one did, because I had to search to the end every single time, whereas this one did not have to search to the end every time. It went to there, it went to there, it went to there, So overall, the performance of this one and this one are about the same. This one has a small edge. Then there are worst case ones. Best case is when it's already sorted, right, and you don't have to do anything. You run through it and you go, wow, I didn't have to do any swaps, I'm done. Worst case is when they're in inverse order already. If this was 25, 20, 10, 15, 1, then as it was bubbling things up, it would have to do a whole bunch of swaps in order to get that to work. And so that would be the worst case performance. Then there are other ones that have different worst case performances. If like I said, some of them are more efficient, some of them are faster, some of them use less memory. That's the difference between a bubble sort and a selection sort. The selection sort's an easy one to remember, I think. Hope you can get that idea. Just search for it, the lowest value, and then swap it, and then search for the lowest value, and then swap it, and then search for the lowest value and swap it, lowest value, swap it, and then you're done, like that. Which method does Java use to sort? probably uses Quicksort. Quicksort is a one that's hard to understand. Let's see if we can go and view the Java doc on this. Sorts the ascended array. The sorting algorithm is a dual pivot quicksort. It offers this performance, which if we know what O n log n performance is, we'd recognize that as being far better than a selection sort or a bubble sort. Quick sorts tend to degrade. It's faster than one pivot. Okay, alrighty. So I'm not going to demonstrate Quicksort because I don't understand it. Whenever I have to learn it, I learn it and then I forget it again. And usually you don't have to learn these things unless you're taking a programming computer science course, right? Because you just use the code that somebody else has written. I would not write my own sort code if I had arrays.sort sitting there unless a professor told me I had to for a grade. And y'all are lucky I'm not doing that. They do give you a code for a selection sort there, if you care. Two-dimensional arrays. You know, not quite often you don't only just have a single list of data. You have a grid of data, like a spreadsheet. So, you know, if you fire up a spreadsheet in Excel, you could just have a list of values, right? I sold $10 on that day, I sold $20 on that day, I sold $50 on that day, 60, 30, and then I took Friday and Saturday off, or Saturday and Sunday off, right? So that was my sales. Yay. What if you wanted to track them, you know, for a year? This is just 1 week's worth. You could have a whole year's worth of sales, right? Like that. Obviously, they wouldn't be the same values each time, or that would be silly. But the way you look at it is we have 7 rows, because there are 7 days in our week, by 52 columns, because there's 52 columns in a year. That's a two-dimensional array. And then we could do things like we could sum up each week, and we could sum up each, you know, your total sales per Monday and your total sales per Tuesday and your total sales per Wednesday, and you might find out that nobody ever comes to your store on Thursday, so why even be there? You know, that kind of thing. And then you could put, you know, a total of the total. And if you're a spreadsheet wizard, you already understand all the concepts of this. So a single-dimensional array, a one-dimensional array, is just a list of data. But a two-dimensional array is a grid of data. And so I think the last thing we want to do today is to show how to allocate a two-dimensional array, maybe fill it with some random data, because random numbers are fun, and then print it out. Let's declare the simplest two-dimensional array first. The way you declare a two-dimensional array looks a lot like the way you declare a one-dimensional array. So just go to the bottom of your code here, and we're going to make a two-dimensional array of strings. I'm going to call it SA for string array. Is equal to, and then put a curly brace there. We're going to use an initializer for this one. Bob, Joe, I'm spacing things out further than you need to. Sam, Sue, don't know why Joe's capitalized and the rest are not. And then lastly, Tim. I start running out of 3-letter names after a while. Abe. All right, I've allocated a two-dimensional array using an initializer list. If I wanted to, I could put this all on one line. I'm going to show it to you. I don't want you to do it, but I'm going to rewrite it so that it's all on one line. Right? And then take out all those extra spaces that we put in there. Whatever. Going to get rid of that. Looking at this, I hope you can see what's going on. This is saying, oh, we have an array. And oh, what do you know? It's an array of arrays. It's a two-dimensional array. Now, are you always going to be able to have an initializer list like that? Probably not. You know, if you knew your data ahead of time always, and that'd be weird. Instead, let's make another array and fill it full of information. Now, how many rows were in this one? This one had 3 rows and 2 columns. So let's make another array. SA2 is equal to new string 3 rows of 2 columns. And let's put some values in it. SA0 sub 0, subscript 0, subscript 0 is equal to Bob. 0-based indexing, just like every other time. This is row 0, column 0. This is row 0, column 1. So Joe is going to be SA subscript 0, subscript 1 equals Joe. I'm going to get bored doing this. I may just make it a 2x2 array rather than a 3x2. But SA1, 0. What should that one be? Which name is that position? Row 1, column 0 is Sam. Yeah. I made that one real easy, huh? Because it was just in order of the rest of them. Yeah, it's not taking that long. I'm going to go ahead and do the last 2. All right. So if I didn't make any typing mistakes, I have 2 identical arrays. And could I have used a copy? System, arrays.copy or something like that to do it? Yeah, probably. If we wanted to print it out, we would not want to see all the data stretched out like this, though. We'd probably want to see it displayed in a nice little matrix like that. To print out a 2-dimensional array, you have to use a doubly nested loop. One to iterate through the rows and one to iterate through the columns. You know, first we're going to print out row 0, column 0. Then we're going to print out row 0, column 1. Now we're all done with that one. Then we're going to print out row 1, column 0. And then row 1, column 1. Then we're going to go back in. So we have an outer loop variable, which is going to be the rows, and an inner loop variable, which is going to be the columns. So let's do that. We're going to write 2 indexes. For int r for row is equal to 0, r is less than, I'm going to cheat for now and say r is less than 3, but I really should be asking the array for those values. We will go back and modify that. This is just for utter simplicity's sake. And then inside that, the columns also start with 0 and go while the columns are less than 2. We have 2 columns. And so then system.out.print I think I goofed something. I said that this was SA2, but then I copied SA over and over and over and over, right? Make all of these SA2s. But when we're printing them out, it doesn't matter which one we're printing out. So print out SA subscript R, subscript C. And this inner loop is going to print every value in that row. And after we're done with that inner loop, we want to go to the next line. So after the inner for loop, let's do a system.out.print line just to move it to the next line. Alrighty, that should print out one of our arrays. It's not going to look terribly good, but all the values are going to be squished together like that, right? But we could fix that. We could use printf to give ourselves some additional spacing. The bigger problem is that we have hard-coded these values. What you want to use is this. Instead of 3, you want to use the array name dot length. Yeah, whichever one I'm printing, you're right. SA2 is cool. SA is cool. Just make sure that they match. So this one's going to be while R is less than SA2.length. In the case of a two-dimensional array, this gives you the number of rows. But we also need to know the number of columns. And this syntax is going to look a little bit weird, and for that I apologize. SA2 subscript C dot length. And is there a better way to do that? Yeah, there probably is. We could try doing this with a for each loop. I'm willing to give it a shot. First, I want to make sure this works. I'm going to put spaces between them, though, just because I like spaces. So I'm going to modify my inner print statement to have this plus end quote there. And there we go. It printed out our little array. So this is the proper way to print an array using an index-based for loop. You have to get the number of rows like that, the number of columns like that. I'm going to take a shot at doing it with a for each loop, but I'm not confident this is going to work. So for every row in the array, for every value in that row, print that value plus a space. And then after that loop is done, see, I'm already getting an error here. I'm not trusting that this is going to work. Never mind. Probably a way to do it. Can't help it, gonna Google. I'll be right there. Print a 2D array using a for each loop in Java. Nah, no way to do it. I say that. You may be able to find it. But that's the syntax. And I really want y'all to remember that because I'm going to give you an assignment where I ask you to print out a two-dimensional array. I know some people had syntax there.